we have a different root this time. The given root is 5i minus 12, and again we need to find minus b over a and c over a if this is the quadratic equation. Now, if alpha, first root, is 5i minus 12, its complex conjugate will be beta. But what is this complex conjugate? We need to be careful. It is minus 5i minus 12. Now, let's find minus b over a as equal to alpha add beta, which is equal to 5i minus 12 added to minus 5i minus 12. This evaluates to the 5i and minus 5i cancels, so we have minus 24. Next, we have c over a as equal to alpha times beta, and this is equal to 5i minus 12 brackets minus 5i minus 12. We have 25i squared minus 60i add 60i as 144. Now, in fact, this is minus 25i squared, because this 5i times minus 5i is minus 25i squared. I squared is minus 1 times minus 25 will give us 25. So this is 25 added to 144, which gives us 169. So there we have it. We've given this one of the roots, its complex conjugate. It's always the opposite sign of the imaginary part. So it's minus 5i minus 12, be careful. Minus b over a is negative 24, and c over a is 169. So without doing any calculations, we can figure out what the relationship of these roots are, which is described as minus b over a and c over a. And that's alpha add beta and alpha times beta respectively. Lastly, we have the root minus 1 minus I. We'll call that alpha minus 1 minus I. And it follows that beta must be the complex conjugate of alpha, which is minus 1 add I. Minus b over a is alpha add beta. If you're wondering where I came up with this notation, if you look at my previous videos, you would see a few videos based on calculating roots of quadratic equations. So alpha add beta, and this is equal to minus 1 minus I add minus 1 add I. This evaluates to negative 2. And c over a is equal to alpha beta, which is minus 1 minus I times minus 1 add I. What's that? 1 minus I add I minus I squared. And this evaluates to 2. So there you have it. Minus b over a is negative 2, and c over a is 2. Thanks for watching. I'm Alistair.